All right. So what we spent time doing before was finding the derivative. So nothing changed as far as that. Power rule, product rule, quotient rule, always use chain rule, trig functions. Nothing new on that. Okay. Now we're going to work the other way and find the antiderivative.
Sir.
So in other words, we're going to take the derivative and go back to the original. Okay, work in reverse. Okay. And this is what we call integration. Right? So an integration looks like this. We have a little integral symbol. And we'll see f prime of x dx on the inside. And this will equal f of x plus c. So the little integral symbol, that squiggly thing, is what's telling me to go back to the original. Now, as far as where some of the pieces are coming from, right, let's look at this. What if I said y equaled x cubed? What would the derivative be? 3x squared. Nice and simple, right? Everybody agree with that? All right, so this y prime would be 3x squared. What if I said it was y equals x cubed plus 7?
3x squared.
Still 3x squared, right? Okay. Everybody agree with that?
Yeah.
Okay, so now remember y prime. All right, we can also write this as dy dx. Everybody okay with that? All right. So instead of y prime, we saw a few different ways. Dy dx. Okay. Well, this means that I can multiply both sides by the dx. Everybody agree with that? Now it's an equation. We can do anything we want as long as we do it to both sides, right? So if I integrate both sides, the integral of dy will go back to y. That's the original from the dy. And this would be x cubed. And we'll talk about how we get the x cubed, but still that was the original it came from. Now the problem is, we call this an indefinite integral because I don't know what c was. I don't have any idea what c was. I know there's a constant there. Even if the constant was 0, that's still a constant. So something was there. Whether it was 0 plus something minus something, I just have no idea what it's going to be. So the plus c is representing whatever constant was originally there. Now there are going to be some times when we can figure out exactly what that c is going to be. But right now it's just that general antiderivative, that integral. All right, so now let's kind of look at what happened here. Here was your power rule. 3 came down, power minus 1. You okay with that? So multiply power minus 1. If you go in reverse, it would be power plus 1 divide. Opposite operation. So derivative, multiply, subtract 1 from the power. Integral, add 1 to the power, divide by the power. So in other words, it looks like this. If I add 1 to the power, divide by my power, it's the x cubed. You're reversing out of what you did. Are you okay with that? Now we have a lot of different integration rules that we're going to work with and such. This is just our first one. So just like when we did derivatives, we worked with the power rule to start with. Okay. So now we're undoing that power rule, and we'll look at some trig ones too. But this guy right here is what we call the indefinite integral. It is basically representing the family of functions. The family of functions. Do you remember what the constant on the end of a function if you added or subtracted a number to? Do you remember what it did to the graph?
Just shifts it up or down.
Shifts it up or down. So right now I'm saying that it's this one, it's this one, or it's this one. They're all the cubic graphs, right? Which one is correct? Well, it depends on what C is. So this is what you call the general antiderivative, the indefinite integral. I can't define exactly which one it is because I don't know this C value. That's the idea. Everybody okay with that? Okay, so now let's work with some of these rules. If I wanted the integral 3x plus 2 dx. So I've got two terms here. That's okay. We just do the first one, finish that one, go to the next one. So this power is 1. So if I go up 1 power, it would be x squared divided by my new power 2 plus 2. All right, what's the power on the x right here?
0.
0, because it's not there. So then if I go up 1, x to the first, divided by my 1. Now, we don't really need the 1's there, but it helps show you we're still using that power piece, and then plus c. So yes, I would write this as 3x squared over 2 plus 2x plus c. Everyone okay with that? Okay. How about integral 4x cubed minus 7x squared plus 3x minus 2 dx. So one term at a time, what would the 4x cubed become?
X to the 4th.
So we have 4x to the 4th over 4, right? Which cancels and, yep, just x to the 4th. How about the 7x squared?
7/3 x cubed.
Okay. So I have minus 7x cubed over 3. And yes, you're right, you can put 7/3 out in front, right, as the fraction does not matter. All right, how about the 3x?
3/2 x squared.
Over 2. Okay. And the last one, the 2? 2x. So minus 2x. Does that look right? Plus the c. Gotta have the plus c on there. Have to have the plus c to represent the constant, the general form. Okay there? All right, so let's kind of think back to something like this when we did our derivatives. When I saw, say, a radical, cube root x dx. Right? When we saw a radical, square root, cube root, fourth root, whatever. Remember we represented those as an exponent? So what would the exponent be for a cube root? X to the 1/3. So the first thing I'm going to do is either rewrite it or at least be thinking of, hey, that's a 1/3 power. Now it's still following my rules. If I go up 1, that would be x to the 4/3 divided by 4/3. So I still followed the same thing. Up 1, divide by my new exponent. And this one would be 3x to the 4/3 over 4 plus c.
Wait, why did you just get rid of the x?
We integrated it.
And then when I saw added x times no, that's a little lost. Wait, because when you need to multiply it out, like multiply the x towards it.
Now this is saying that this was the derivative. So when we went back and integrated it, we're back to the original function, not the derivative piece. Everybody okay there with the root? Sometimes a little bit of a pain because of fractions. Well, this one. Now you're back to remembering the trig functions. Is it negative sign?
No.
No, just sine. Sine x plus c. Usually when I see the trig functions like this on an integration, I always used to do this. I still do it sometimes. Instead of thinking of the integral, I'm going, all right, cosine was the derivative of what? Because I remember my derivatives. All right, and I just got to go backwards from there. So if I saw something like this, sine theta, d theta, first off, I switch variables, doesn't matter. Whatever variable's in there is what we're working with. So then I'm thinking, all right, the sine of theta is the derivative of what? Right, so I'm thinking, all right, wait a minute. Cosine's derivative was negative sine, not positive, so then I'm going to need that negative on the cosine. Negative cosine theta plus c. Are you okay there?
Yeah.
All right, so integral x squared plus 1 over x squared dx. Now, at this point, we've got this power rule we're working with or undoing. Now, power rule, not a quotient. Okay? This would be another situation where I want this rewritten so I can work that power rule. So I have x squared over x squared is 1. And then 1 over x squared would be a negative exponent. Everyone okay with that? So now the integral of 1 x plus, if I go up by 1, x to the negative 1 over negative 1 plus c. So I'd really guess I'd have x minus 1 over x plus c. I don't mind having negative exponents in there, that's fine, but we've seen them move around and get rid of them before. So remember, we need an exponent. Same way we got a third there. Sometimes we need a negative exponent. So if I saw this, 3 over x to the 5th dx, well, I'm going to bring that 5 up. So instead of 3 over x to the 5th, I'm thinking of it as 3x to the negative 5. Are you okay there?
Yeah.
So what's my new power?
X to the negative 4.
Negative 4 over negative 4 plus c. And there's nothing wrong with this, but we could also bring the x to the 4th down. Doesn't matter to me, you know either one's correct. So I don't have quotients. I have this power rule that I'm undoing. I'm going through the antiderivative on that. So if I have a quotient, I need to get it in a form I can work with these powers. If I have a root, I need to understand what the exponent was. If you had a product, let's go 3x plus 2 times 7x minus 1 dx. I'm going to have to multiply that out so then it's back into that polynomial formation so I can use the exponents. So I'm thinking of this as 21x squared plus 11x minus 2. Then I'm ready to go through it. So if I go up 1 power, x squared goes to x cubed. So this would be 7x cubed plus 11x squared over 2 minus 2x plus c. You okay there?
Yeah.
All right, so if you can get it back into this formation, I'm not going to say they're all easy, but you start getting really quick with that power rule or undoing that part. Okay, there's times we have to do some rewrites to make it easier for us. And then we've got 6 of them that we got to know from before. In fact, nothing changed on those. Okay. All right, let's take a look at homework.